hierarchical clustering. So I'm using the same data set DF, wherein I have taken 4 variables: MPG, weight, horsepower, and automatic or manual transmission. What we are doing is, next step, we are creating a variable DFD, that means distance of DF. So it will create a distance matrix of our data set and will be saved in this variable. So for to calculate distance of the variables in DF dataset, the formula is dist. Let's execute it and look at the values. So you will see a number of variables here. What does it mean? Let me show you. There was a data set that we created in our last video, that was of exam, that is marks 1, marks 2 and project, and we scaled it so that it is in same scale. So this is my data set. It looks like after scaling. So what I am doing is I am calculating distance of each of the variable in my clusters using the method Euclidean. So distance will be calculated for distance between each of the variable in this data set. So this is how it looks like. The distance has been calculated using Euclidean formula. This is the Euclidean formula that is used here. It's square root of difference between the first value and the second value square, and similarly adding it further. So this is how each of the distance of each of the variable is created. We will be using the distance variable here, the variable containing distances of our data set, to create our hierarchical clusters. To create hierarchical cluster, the function that is used is hclust, within the bracket name of the data set that you are using, and we will plot it. Let's zoom it. So this is because of the distance that I have here. So there is a brush button here. You can see each of the pane, there is a brush button. If you just want to clear your console, just click it here and you will be able to clear your console or your plot area. So I am saying create hclust and plot it. So this is how my dendrogram looks like. So in hierarchical clustering, as we discussed, it creates small clusters, then it is joined with bigger clusters, ultimately creating the biggest cluster, that is joining the whole cluster into one. So here you can see, if I mark it, so these are the first clusters that are created. These are the closest variables, or you can say observation, in our data set. So they are clustered together, they are in a one similar cluster here. So this is how the first clusters are created. Now this cluster is joined with a bigger cluster, that is one more observation, and the bigger cluster is created. Once this cluster is created, it has been joined with another cluster, another bigger cluster, then with another bigger cluster, using this cluster and the whole cluster here. So this is how each of the clusters are created, and at the end we have whole data here in just one cluster. So this is how a dendrogram looks like. And also, if you want to understand the agglomerative and divisive clustering, so what does it mean? If I say agglomerative, it means it starts from the bottom one and goes up till the highest one in the highest cluster. It means agglomerative. And if I say decisive, it will cut the clusters into smaller groups starting from the biggest one. Now what we will be doing is we will cut tree into 4 groups. So how will we cut our tree into 4 groups? So I'm creating a variable subgroup. I'm using the function cut tree, and within the bracket, first thing is the variable containing the model here. So HC is my model variable. Then I am mentioning the number of groups that I want to cut my tree into. So I want 4 cuts, that means 4 groups. Number of members in each clusters. Now 4 clusters have been created. I want to see how my data is transferred to each of the group. For that I am using table command. So these are the 4 groups in this whole dendrogram that are being cut to 4 groups, as I can say. Now 17 cars are being allotted to first cluster, then 8 cars to second cluster, 6 cars to third, and 1 to fourth cluster. So let's see how can we check if there is, what are the cars, how the clusters, where the cluster is last divided. You got AB line. Now we are creating a model using average method. So average method was wherein each of the variable in each cluster is compared. The distance is calculated for each of the points, and the cluster is created. So I'm saying save it in HC average. The function used is hclust, then the name of the data frame that you are using, and method is average. Let's execute it and check it. So it tells you that the method used is average. Distance is calculated using Euclidean method, and number of total observations are 32. So 32 observations will be divided into different clusters here. So I am saying plot this model hang -1. So hang -1 means the car's name here, as you can see in the graph. You can see each the car name is where the cluster ends. So if you do it -1, it will be in one line here. So it will be equal, and CEX equal 0.8. The font size of the car names observations here will be reduced to 0.8, and the title of my graph will be average linkage clustering. Let's execute it and see. So this is how my graph look like. Now you can see in average linking there are different clusters here. This is one cluster, this is second cluster, third cluster, and fourth and fifth cluster. So you can create different clusters within the graph also. Let's see how can we do that. By doing hang equal to -1 also, you can see all the cars are in one line now. All the name are in one line. Now we will be cutting our graph. So rect.hclust, it means a rectangular cut will be made to our graph, wherein there will be 4 clusters, 4 groups, and border means, and the border of each of the cluster will be from 2 to 6. So they are the colors, color range from 2 to 6 for each of the cluster that have been created. So you can see in the same graph different clusters are created. So this is the one cluster, this is one cluster, then this is the second cluster that have been created, this is the third cluster, and the fourth cluster. So this is how you can cut your tree using K, that is number of clusters. So there are 2 types. You can cut your dendrogram using K, that is cluster cut, or H, which means height cut. So next is the height cut, wherein you will say, let's first create the original one. So this is the original graph that we are working upon. Now I am saying here, earlier I mentioned K equal to 4. Now I am saying H, that means height equal to 100. So the height where my scale is 100, there will be graphs created. So here you can see 3 groups are created at the level 100. This is the first cut. So this is the first cut here. Then this is the second cut, and this is the third cut. So this whole has converted into one cluster. This all is into one cluster, and this is in a single cluster. So this is how you can make different clusters, and also you can create a line wherein you want to cut the graph. And let me tell you all the cuts that we created in the final graph. So this is our final graph, wherein we used K cuts here, showing different colors. They are the graphs at 4, wherein we said we want 4 groups. So at this point it created 4 groups. Then we wanted at height 100 to be our graph to be cut. So here there are 3 groups, and it is the AB line, that is the height equal to 100. This is how our graph is created for hierarchical clustering.